service like this, because there is the danger you switch it on, everyone goes crazy, speed tests, completely crashes it, or do you just go, actually, we'll let everyone have 20 megabits per second because that's so much better than the 3 before. So yeah, we do work with them. There's no one set answer, unfortunately.
And so what's kind of the theoretical maximum speed you could be getting through the antenna technology? I know you said your switching technology in your current deployments is kind of only 1 gig lines, but do you see kind of upping those to 10 gigs or even like
so our internet connection
multi 20 gig connections?
Yeah, we'll be upping our Isle of Wight connection up to 10 gigs. We don't expect to reach the 10 gigs, which means we don't have a limit. As you saw, we're already achieving near 2 gigs. We expect to be able to push that.
Can I jump in with a question that's coming from someone online? You talked about Basingstoke and Earlsfield. What are the plans for rolling out this technology on the mainland rather than the island? So
Basingstoke and Earlsfield is mainland. It's the busiest routes going into London. In fact, I think it's one of the busiest routes in the UK. So that would be brilliant. I think for the rest of the UK, there's onward discussions with at least one other route at the moment. A lot of that comes down to the governance that goes around railways. So you have train operating companies, you have Network Rail, you have Network Rail Telecom, you have OR, you have DfT, you have the Treasury. So there's a number of people that need to be supporters of this to make this work.
Yeah. So the Earlsfield route is already a project?
Yes.
Oh, right. Okay.
You can already see the antennas on the trains.
Okay.
Any other questions?
Hi, Carl.
Be nice.
I couldn't let you get away without a question from me. A couple of quick questions, really. So, first of all, how many megahertz are you running on each of your small cells, effectively?
I don't know. And I was in the car on the way down here. I thought someone's going to ask me a really radio question, like how much bandwidth or what's the exact spectrum you use? I don't know. I'm more than happy to find out and let you know.
Okay, you've got my number anyway. You've got my number anyway.
Yeah.
Second question: what's the sort of typical density of the sites? So are they every couple of 100 meters, or how?
That's a really hard question to answer. Actually, it really depends on the environment. It depends what the customer wants to achieve out of it. We're talking somewhere between 900 meters to 2 kilometers, depending on what the environment is.
It was interesting looking at the throughput graphs that you've got there, and sort of you kind of first wonder if you were reducing or increasing the density, increasing the number of sites, what that would do to the throughput, and coupled with that, any fiber backbone access point limitations. If you were unlocking that from 1 gig to 10 gig, as you mentioned earlier, what that would do to the throughput. So I'm trying to work out if it's radio spectrum limited that's giving you your ceiling there, or if it's inter-site distance that's giving you the ceiling, or is it the backbone fiber that's giving you the ceiling?
Certainly not the backbone fiber. There's opportunities to both the radio and the density to improve.
Thanks, Carl.
Okay. So there's a cluster of questions around a similar theme. Thinking about the resilience of the network, is it suitable for use in safety critical environments? So the sort of airwave type situation, and then related to that, what about the threat of cyber crime and hacking? Is that something that's a real consideration?
So let me talk about the safety critical part first. So we didn't design it for safety critical initially. We do, though, have an approach which would allow it to have full redundancy in that. Now, obviously, that changes some of the architecture. It definitely pushes up some of the cost, but it has the ability to do that. And we're talking to an operator in Europe at the moment around if what we're proposing would work for them from a safety critical perspective, looking at also integration with systems like FRMCS, which is like a safety and coordination system. So it can be, it's not been designed to do that today. From a cybersecurity perspective, then yeah, absolutely. We are not going to go into details of what we do to secure the network. But yes, we take that very seriously.
Well, that's reassuring. I think there's a lot of worried people out there at the moment, because another thread of conversation is about you're powering by solar, and obviously we're worried in general about lack of power and blackouts in all sorts of areas of the country in the next few months, perhaps. So, how would that affect the network, both in terms of the power of the masts themselves and also the backbone that you're using to connect it to the rest of the world?
Yeah. So, yeah, in the design we have today, we don't put in power backup. We do have power backup systems that we've designed. So obviously with the solar, we've used a range of battery technology to be able to store power overnight, and we can deploy that as well if it's required. For the core backbone, the switches and the firewalls, they can also be supported with UPSs or battery backup as well. The deployments we've got at the moment, we've got space for that if we wanted to. But at the moment, we haven't had a requirement to make sure that we've got that in place.
You'd certainly have an awful lot of batteries out in the field. If
you do get a lot of batteries, and they do weigh quite a bit. The other thing around the switches part is actually we can set up the fiber systems where we can manage off 2 switches at the same set of networks. So actually we get a full redundant system. So if we lose power in station A, we have power back in station B. If we lost the whole country, it's not so easy.
Great, thank you. I feel like I'm an expert on 5G now. I was attending a IET lecture on 5G a couple of weeks ago. I'm obviously not, but I understand what allows you. Part of what allows you to do this is, I think it's only 5G, but correct me if I'm wrong. You can have your own network with 5G as an operator. So you have a local network. I was interested when you drop the challenges on the experiments you've done so far. The one challenge you don't seem to have tackled was the proximity to densely populated urban areas, which have their own broadband, cellular networks and such like. Is that it seems to me that could be a real issue, because you'd be potentially conflicting with other network providers, and therefore spectrum and management would become much more of an issue. Am I right in that?
Spectrum management could be an issue if there was lots of other people using this millimeter wave band. Reality is there isn't. There's a number of other things actually that mitigate that risk. So one is we're in the middle of a railway, and we have quite a bit of distance between us and even a block of flats that's right next to it. The other is that we have a range of technologies inside the transmitter and the receiver that allows us to mitigate interference. And then thirdly is, we talked about that pencil beam, because it's very narrow, it's very powerful. It means that it's the area that it can be interfered with is quite limited, because you can interfere where that pencil beam is. So there is a risk. It's very, very low of there being interference from others working the 60, 70 gigahertz band. Okay.
So I guess as you talk about this, it makes me think as we build new railways, this should be going as a standard. So HS2, they're putting the whole, they're putting the tunnels in at the moment. Is there thinking that potentially will this work on high-speed trains? Is this something that we should expect that we would see on kind of, as rail build out still happens?
So it definitely will work on high-speed trains. We've tested on high-speed train routes. We know it works. In fact, today I was asked if it would work on a train going a ridiculously stupid number of kilometers now, which hasn't even been built yet. But so yes, it's ideal for high-speed routes. Is it being considered? You'd need to ask Network Rail Telecom HS2. We definitely are lobbying and pushing and explaining this is a technology you should consider. Like I said before, it might not be the right technology for all locations, but it's something we think should be in the mix.
Yeah, I think that will be the last question.
What are the most challenging environments for your aerials? Are there particular things? You talked about tunnels, you've spoken about the pier, you have to head out into the pier. What's the most difficult you have to do when you're playing around with your posts? Your puzzles?
Drainage ditches. Seriously? I think that, yeah, I think it's two things. There are certain, so in the UK, I'm going to talk about the UK because it has got some of the tightest regulations. There are very clear guidelines around how far you have to be away from the track, how far you have to be away from other things, how close you can be to the train, and then how close you can be to various bits of infrastructure on the ground and everything else. So that in itself creates a problem, but actually it is things like drainage ditches, because if you imagine you've got a railway, it's got embankments. So actually that's quite a challenge because you've got to be able to place it somewhere. And so then you want to push it back as far into that embankment as you can, but then there's a drainage ditch the other side, and then you can't block the drainage ditch. You've got to make sure there's a walkway. So you end up having to do quite a bit of civil engineering to be able to get that in place. Fortunately, they're few and far between those sort of scenarios, but there are some like that are quite interesting. So yeah, there are civil engineering challenges that I never expected us to find, but we have, and we've sorted out.
Okay, and with that, I think we've given you enough of a grilling, and thank you very much for taking the questions from all the people in the audience here, and also from those people online that I was able to relay to you.
Thank you very much.
A good presentation, and I'm sure you'll, in the room, join me in thanking Carl in the customary way.
Thank you.
So we're almost done, but I'm just going to hand over to my colleague Colin to just remind us about what's happening next and the world that is the IET in Surrey.
Thank you very much. Could I just amplify what Nigel has said and thank Carl a lot? There were some hugely detailed practical issues that he dealt with, and these are the kind of things that we're going to have to live with and get used to over the coming decades, I guess, as people realize just what is possible and what can be done in increasingly complicated situations, in this case like railways, but there are other forms of transport as well. So thank you. That was very detailed, very knowledgeable, and highly practical. Let me just return to our next event. Now, I would like you all to take away this message. We are running a lecture on the 8th of December here. That's a Thursday evening, and it's mainly aimed at older school children. Part of our mission is to encourage people, younger people, to consider the possibility of a career in science and technology, and specifically in engineering. And so we aim every year in our December lecture to present an interesting topic that will capture the imagination of young people. So this year, we're particularly pleased that a very long serving expert in the Surrey Space Centre, Professor Craig Underwood, who has spoken to us before and is an excellent speaker, is going to talk about the next phase of lunar exploration. Now, we are aiming this, as I say, principally at older children, but I would ask you all, if any of you who have children, grandchildren possibly, more in that region, or friends who have children, please spread the word. We will be putting out information to schools, but anybody you know, remember the 8th of December, 7 o'clock in the evening. Now, it will be like tonight, it will be a hybrid lecture. It will be here in our main lecture theatre, but we will also be putting it online for people who live sufficiently far away that it's not practical, particularly for schools, to come and actually be here and ask questions in person. But it will be a very detailed lecture, and Craig is a very, very knowledgeable person in the space business. As I say, his background here in Surrey goes back over 30 years. So 8th of December, 7 o'clock in the evening, live and online from here. if any of you need more details, if you look at our website, and for those of you who are not familiar with it, it's very simple. It's the iet.org/Surrey, and that will get you a start to getting the information. Now, finally, I would say, for the benefit of people here tonight and for our audience, we have, at least hopefully, we have got a recording of this. And once we've, in fact, processed it, just to shorten the start and finish of it, we will be putting this on our YouTube channel, which we've been running very successfully now for a couple of years. And on that, all you look for is IET Surrey Network. If you go into YouTube and look for that, you will come up with the repertoire of recordings that we have been building up over the last couple of years. But finally, thank you very much for coming tonight. It's a delight to have seen you all, and have a safe journey home. And if those of you can, we'd love to see you in December. Thank you and good night.
Well, we finished in good time in the end. That was really good.
Recording stopped.
Yes. So it was the camera connection that was causing us grief at the start, wasn't it? That's all it next needed to be grief. Because audio wasn't a problem at all anyway, or was it? Because we did